Hello, my name is Eduardo Maya, and I'm going to be talking to you about the research that I did measuring iron concentrations in individuals with Cribra Orbitalia and Porotic hyperostosis using portable X-ray fluorescence, or PXRF. Now, this is a study that was done under the guidance of my mentors, Drs. Brittany Kyle and Marianne Hamilton. So, before I can really get into the meat and bones of my research and why I chose to do my research, there's a few topics that I must first explain. Those being iron deficiency anemia, Porotic hyperostosis, Cribra Orbitalia, and the iron deficiency anemia hypothesis. Iron deficiency anemia is simply the case where an individual has a lack of healthy blood because they are not getting enough iron. This lack of iron could come due to a number of factors, such as environmental conditions, which don't allow that individual to consume iron into their diet, or because they have parasitic infections that cause bleeding in their gut, which then does not allow them to get all the iron that they consume. Next, Porotic hyperostosis is a pathological condition which is found actively only in adults, meaning that we do not find Porotic hyperostosis in younger individuals. This condition is identified by porosities or holes along the parietal bone, as we can see here in this individual. The parietal bone is just this area that we all have here along the side of our skull. Next is Cribra Orbitalia. Cribra Orbitalia, on the other hand, is found only on the upper eye orbits, as seen here in this individual. And Cribra Orbitalia is a condition which is found actively only in young individuals, meaning that when we find it in adults, we find it typically showing signs of healing already. Next, the iron deficiency anemia hypothesis. The iron deficiency anemia hypothesis is pretty much a way that puts together these topics that I just explained to you. And this hypothesis states that iron deficiency anemia directly causes Cribra Orbitalia and Porotic hyperostosis. Because you might be asking yourself, how can this hypothesis state that we go something from like a disease such as iron deficiency anemia to a condition such as Cribra Orbitalia and Porotic hyperostosis? Well, the hypothesis goes a little something like this. When the body notices that we do not have enough iron, it releases a hormone called erythropoietin. The purpose of releasing this hormone is so the body speeds up red blood cell production in the bone marrow. The iron deficiency anemia hypothesis states that when erythropoietin fails in producing enough bone marrow to make the body healthy again, then the body has no choice but to produce more red bone marrow, which would then produce more red blood cells. For those that do not know, our red bone marrow is housed in different areas along our body in this sort of spongy bone. As we can see here in this example, we also have some of this spongy bone here along the parietal bone and the upper eye orbit, as we can see, which is that area which we see Cribra Orbitalia. Now, the hypothesis states that when red bone marrow is forced to expand, it will also expand this spongy bone area that we see here in this depiction that surrounds the bone marrow. And in return, it will also force the compact bone and the periosteum to recede. These two layers are what surrounds the spongy bone and the bone marrow. Now, the hypothesis states that this spongy bone area, as you can see here, would be exposed, and exposing these holes would lead to the condition that we see in Porotic hyperostosis and Cribra Orbitalia. So the iron deficiency anemia hypothesis is not something that is set in stone, and in fact, there's actually a lot of controversy behind whether this condition actually causes Porotic hyperostosis and Cribra Orbitalia. One of the most famous rebuttals against the hypothesis come from Walker et al. 2009, and they cite a lot of medical literature stating that iron deficiency anemia cannot cause these conditions for a number of reasons, such as that an individual with iron deficiency anemia could not produce enough red blood cells to cause that red bone marrow to expand outwards, and in return they provide another possible solution, which is megablastic anemia. And on the other hand, a rebuttal of that article comes to us from Oxenham and Calvo 2010, 1 year later, pretty much saying that Walker et al. 2009 is citing medical literature incorrectly. Now, regardless of what you may believe when it comes to these two authors, the fact holds that Cribra Cribra and Porotic hyperostosis have been used extensively to estimate the health of individuals when they are found in the archaeological record, based upon our understanding of what causes these conditions, being that iron deficiency anemia in the future, in the past, or other anemias or environmental conditions. So that is where my research comes in. Now, it's important that I mention that my research is not directly testing the iron deficiency anemia hypothesis. That is too big of a research project for my undergraduate time in McNair. What I am doing, on the other hand, is testing the reliability of a new method that could be used in the future to test the iron deficiency anemia hypothesis, and that method being portable X-ray fluorescence, or PXRF. And I will go into detail of what PXRF is and how I used it here shortly. Aside from using PXRF, which is a new method, I also used standard methods in literature, which are used commonly to build the biological profile of individuals when they are found. To build the biological profiles of individuals based upon their remains when found. What I mean by biological profiles is getting an idea of the sex, age, and disease of each of these individuals. Now, once I collected my data using those two methods, XRF and the standard methods, I was able to run my data through various students' t-tests and use various graphs to analyze my data. And that led me to the conclusion and the ability to determine if there were iron concentration differences between individuals that had Cribra and Porotic hyperostosis when compared to those that did not. Here is an example of some of the standard methods that I used first to estimate the sex, age, and pathology of my individuals. The first example here is a method which uses dental eruption to estimate the age. If I can jump over here to number 3, this is an example of what is used to estimate the sex of an individual using the frontal eminence or the chin. And finally, here is the method that is used to identify the degree of pathology based on Cribra and Porotic hyperostosis. You can see here the one on top concentrates on the parietal bone and how severe it is, while the one on bottom concentrates on the upper eye orbit. Next, to give you an idea of what I was using, of what PXRF is before I tell you what I did with it, PXRF is a handheld device which has the capability of conducting research in a non-destructive method. What PXRF does is it takes element concentration readings from pretty much anything that you choose to scan. What it does is that it emits an X-ray which knocks out a proton in an atom. This atom is then forced to replace the proton that is knocked out, and that switch of having to replace that proton releases an amount of energy that the XRF is able to pick up, and this amount of energy is different for each element, and that is why we can tell the different elements concentrations that are in whatever it may be. Here is an example of a spectral analysis that is able to be generated through the XRF, and it's just pretty much showing us the proportion of the elements to each other. The data that I actually generated with the XRF is much more extensive and is quantitative in nature. Here is an example of me using the PXRF, and as you can see here, it requires that the object be placed on it flat, else the X-rays go out to the sides and measure the surrounding air and not the sample itself. Here is an example of my spectral analysis that I was able to generate via one of my samples. For my results, and after analyzing the extensive amount of quantitative that I was able to get from the XRF, I ran that through a student's t-test and came to the conclusion that the probability of those groups being different was not very likely. In fact, it was upwards of 26%, while I would have liked it to be within a matter of 0.05 probability that these samples were different. Next, looking at my data through this scatter plot, we can see that pH, Porotic hyperostosis, pathology degree, pretty much has no relation to iron concentration as I found it. And looking at this box plot here, we can see the variance of the iron concentrations that were found in our groups. And as you can see here, the iron concentrations were actually higher in individuals that had porotic hyperostosis when compared to those that did not. That is something very important to mention because seeing iron concentrations higher in individuals with porotic hyperostosis is actually the opposite of what we would expect to see if the iron deficiency anemia hypothesis was true. This is very interesting, and I currently do not have a way to answer why we might see this, but I believe that further time spent analyzing the extensive amount of data that is generated through the XRF will lead me to some results in that question. Next, for my overall question of seeing if asking if PXRF is a reliable method for testing the iron deficiency anemia hypothesis, I believe that I can strongly and confidently say yes, that PXRF is a good method for testing this hypothesis in the future. It is portable, it is non-destructive, and compared to other methods, it is relatively cheap. The time that I spent with PXRF using it was spent indoors, and aside from having to stand in a chair for several hours, there are few discomforts to using PXRF. Lastly but not least, if there's any other questions that you would have, please feel free to reach out to me. Eduardo Maya, here's my phone number, my email, and please, if you do have the time, reach out to me on LinkedIn. I'd greatly appreciate it. Before I head out, I just really like to thank the McNair Scholars Programs, because without them, their help and their support, I really wouldn't have the opportunity to do this research project. And I'd also like to thank my mentors, because without their support, I would not have the capability to continue to actually do that research project and continue on my education into the future, which I'm very thankful for. So thank you, everybody, and you have a great day.